Hello, this is Mr. Craig, and this is Day 6, Homework Explanations. I went through and went over the examples for Day 6 in a recent video, and if you're not sure about what percent composition, empirical formula, and molecular formula actually deal with, I highly recommend that you go and listen to that video, or watch that video. It's a very good video. It actually is about 45-46 minutes, so if you need to, you can fast forward through some of the parts if you need to. So I plan on going quickly through the homework explanation to the answers here in anticipation that you've already watched that video and you have a pretty good understanding of those three things. And don't necessarily think that these three things are kind of minimal or minor. These are pretty important concepts. These are actually very, very important type things that often aren't discussed very often in general chem. In AP Chemistry, we need to know how to calculate empirical and molecular formulas. And what's nice about this is, I think in general chem, when I taught it, I would teach the percent composition one day, and then I'd teach empirical formulas another day, and then I'd review over that, and then we'd go over molecular formulas. Well, in AP Chemistry, that's a tool that you should already have in your tool belt, and you should be very, very, very good at being able to do these types of problems. So, and if not, you need more practice with this, or you need more problems, I can definitely direct you in the way or give you some more problems to work on when doing this. So yes, you will see empirical formulas on the AP exam. After spring break, we will definitely talk about empirical formulas again in part of the review for the AP exam. So don't just blow this off and think, oh, I remember how to do that back in general chem. These are three very, very important topics or skills here. Alright, so number one, calculate the percent composition by mass of the following compounds. So we have this acrylic acid, which you don't need to know the name of that. We'll talk about what acids you need to know later on. But the first thing that you need to do is find out what the molar mass of this compound is. So in this case here, we're going to work with 1 mole of a compound. It just makes things a lot easier for you to do these calculations. If you worked with only 0.33 moles, you would still get the same percentages. So make your life easy and go with 1 mole. So once we have the molar mass for the compound, to find the percent composition of each of the elements within the compound, we need to find out what the individual elements' mass happens to be, or what their mass contributes to this compound. So for carbon, we have 3 carbon atoms in this compound, and the total molar mass is 72.06. So take that value of the carbon's mass divided by the total mass, multiply that by 100, and we get approximately 50%. Now again, I'm rounding here so that I have 1 decimal place. Hydrogen, doing the same thing, get around 5.6, and the oxygen's around 44.4. And if I do my math right or correctly, then these should add up to 100%. And I may be off by a 100th or so, but hopefully I'm not off by a 10th, but I could be. Alright, letter B, C2H3Cl3O2. Again, find out what the molar mass of the whole compound is. That's the first thing that you have to do if you want to find percent composition. And then once we have the total molar mass, then we'll find our percentages based on the mass of each of the elements, and then we can find out what the percent is. So check your work here. Hopefully everything looks in line and correct here. I think I'm off by a 10th on this one. Okay? Alright. Number 2. One of the most commonly used white pigments in paint is a compound of titanium and oxygen that contains 59.9% titanium by mass. Determine the empirical formula of this compound. Now, some of you may have read this question and thought to yourself, well shoot, he didn't give us the percent of oxygen. Guys, this is a problem-solving type class. So if I had told you that there's only 2 things in the compound and that I gave you a percent for one of those, I would hope that you would be able to determine the percent of the oxygen. So knowing that, the titanium is 59.9%. Make sure that you can find out what the oxygen is, or the other element. So we're going to first of all find out the number of moles for each, the titanium and for the oxygen. Okay, so if we have 59.9% titanium by mass, then we're going to have 40.1% oxygen by mass. Again, as I said in the lecture video, assume that you would have a 100-gram sample. That just makes your percentages and your masses so much easier. If you said you only had a 50-gram sample, make those masses accordingly, okay? But a 100-gram sample just makes things so much easier. All right, so I get 1.25 moles for my titanium, 2.5 moles for my oxygen. Now, that's our number of moles. What we need to now do is find out what our mole ratio is. So whichever of these two values is the least amount, and it looks like the 1.25 is our least amount of number of moles in this compound, that's what we want to determine our ratio from. So we'll divide everybody by that lower amount. So we have a ratio of 1 for the titanium, and it looks like we're going to have a ratio of 2 for the oxygen. So our ratio is a 1-to-2 ratio, which means that our empirical formula is 1 part titanium, 2 parts oxygen, or TiO2. Okay. If I were to ask you what the name of this would be, hopefully you would say it would be titanium, since it's a metal, titanium with a Roman numeral 4 oxide. Titanium 4 oxide. Always good practice to be able to name certain compounds. Now again, we know that it, well, you don't know that it actually has a Roman numeral here, but it is a transition metal, so yeah, it's pretty safe to say. We'll talk about it later. All right, number 3. An unknown compound contains 716.5 grams of chlorine, 242.7 grams of carbon, 40.7 grams of hydrogen. In that order, again, as I said in the lecture video, make sure that you're writing these elements in the order that they're listed. I want you to determine the empirical formula for this compound. So you're given grams here, so convert those grams directly into moles. So we'll do that for the 3 elements that are given here. So you come up, or you approximately get 20.21 moles of chlorine, 20.21 moles of the carbon, and 40.38 moles of the hydrogen. Since we have similar mole amounts, we're going to pick the lowest one to determine our ratio. So we're going to divide everybody by 20.21, which means that the chlorine and the carbon have values of 1, and then we have twice as much hydrogen, mole-wise, not mass-wise, mole-wise, as we do of the other 2 compounds, or 2 elements. So my empirical formula is a 1-to-1-to-2 ratio. Okay, so we have a 1-to-1-to-2 ratio, which means that we have ClCH2. Now, some of you might think, wow, that looks a lot like an iodine. I will tell you right here, right now, nature does not like to put carbon with iodine. And I'll make sure that if that is an I, it'll be a very, very, you'll know that that's an I. But the good news is we never see C and then I following that. Nature just doesn't like that, so we don't do it. All right. Next question. Number 4, a sample of diethyl glycol, which is antifreeze, contains 45.27 grams of carbon, 9.5 grams of hydrogen, 45.23 grams of oxygen. Determine the empirical formula for this compound. Just like in the last question, you're given the mass amounts, convert those to moles. Once you have your mole amounts, then we're going to decide which of these has the lower value. And it looks like the oxygen has the least number of moles, so that's going to help us determine our mole ratio. Now, when you did your calculation, you may have found out that, oh, I got 1.3 repeating. And then for the hydrogen, you got 3.3 repeating, or something very, very close to that. What we need to do is change that decimal into a fraction. Why? Because we need to have whole numbers. We can't have fractional subscripts. That just doesn't look very good. So, once you change that, whatever the number on the bottom is, that's what we're going to multiply everybody by to get a whole number. So if you multiply the top one by 3, you got to multiply everybody by 3. If you multiply by one thing by 2, you got to multiply everybody by 2. So make sure that everybody gets multiplied when working out these empirical formulas. And again, what we're looking for is whole numbers. But more importantly, we're looking for the smallest whole number ratio. So if I would have happened to get an 8, a 20, and a 6, I know that I can reduce that down even further. Can I reduce 4, 10, and 3 down any further and still have whole numbers? The answer is no. So my ratio for this compound is 4 to 10 to 3. So my chemical equation is C4H10O3. Okay? All right, number 5. What are the empirical formulas for these molecular compounds? Again, we're looking for the smallest whole number ratio. So since we have N6O15, well, these are not both divisible by 2 or by 6, but they are divisible by 3. So we'll divide those by 3 and we get N2O5. Looking at this one, we have an 8, an 18, and a 2. The bad news is these are only divisible by 2, so half. So this is the empirical, this is the molecular. Okay, make sure that you can distinguish between the two. And sometimes, and it's not meant to be mean or cruel, but sometimes the empirical formula is the molecular formula. It just happens that way. So don't be upset if you are given a problem like that, and I think we may have one on the homework, or if you see one on the AP exam. Just like I said in the lecture video, most of the time, well, I shouldn't say most of the time, a lot of times when they have you define molecular formulas and empirical formulas, the molecular formula is the same as the empirical. Not all the time, but a lot of students seem to get frustrated by that. And that's okay. All right, number 6. A compound containing only sulfur and nitrogen is 69.6% sulfur by mass. The molar mass is 184 grams per mole. What is the empirical formula of the molecular compound for this compound? So again, I've done that to you, where you have sulfur and nitrogen, but I only gave you the percent of the sulfur. So you should be able to determine the percent of the nitrogen. Okay, so just take 100 and subtract it, or take the difference of 169.6, and that'll give you your percent of the other. All right, so find out your number of moles, whichever of these two is the least amount. Now these are very close, but we're going to go ahead and use the smallest value. Now again, if you haven't watched the video, the lecture video here, I've given certain values that I want you to get your decimal place as close to. So 0, 0.25, 0.33, 0.5, 0.67, or 0.6 repeating, 0.75. If they're very close to one of those, that's the one we go to. We just don't say, well, it's 0.25, so I'm going to round down. Don't do that. You're going to miss a lot of points on these empirical formulas by doing that. Here, 2.18, let me get back here, 2.18 divided by 2.15, that's 1.0139. Okay, that's only off by a 100th. So we're fine there. We can live with that. So our ratio is 1 to 1, and so my empirical formula is SN. Now this is asking for the molecular formula as well as the empirical formula. So we have the empirical formula. So now the molecular formula is the equation where you have N is equal to the molecular formula mass over the empirical formula mass. Now this value right here, the 184, or the number on top, will always be given. Somewhere in the question it's given, like somewhere like right there. And then the empirical formula mass, you have to calculate after you determine what the empirical formula is. So in this case here, we have 1 sulfur, 1 nitrogen. So we'll add those two values together since it's a 1-to-1 ratio. And then our empirical formula is that multiplier. So since the N is equal to 4, then our final answer should be S4N4, since we're multiplying the S and the nitrogen by 1. Or they have subscripts of 1, and we're multiplying it by 4. Okay? And yes, I need to see all of these steps. Don't necessarily need to show that one. It would be very, very nice to show that instead of that. Okay? So on the AP exam, they're going to want you to detail all of your steps, show your process, and just get used to that here in the summer, because when you come back in the fall and you're just giving me answers that your calculator is giving you, you obviously haven't watched the videos or you're not paying attention. So make sure you're showing the detail. Okay? And you may have heard that the devil is in the details. All right, number 7. A sample of hydroquinone, a chemical used in photography back in the day when they used to use film, contains 65.43 grams of carbon, 5.5 grams of hydrogen, and 29.1 grams of oxygen. What's the empirical and molecular formula if the molar mass of the compound is 55.024 grams per mole? So again, same thing. Find the empirical formula first, and so we find out how many moles and then determine the mole ratio. So we have a 3 to 3 to 1 ratio, which means that our empirical formula is C3H3O. Okay. And then we have to find the empirical formula mass based on our empirical formula. So this is something that you will always have to do, okay, when doing these types of problems. To find the molecular formula mass, to find the molecular formula, we need to go back to the question, find the molecular formula mass, which is right there. It was given to you. The molecular formula mass is right there. So what we need to do is we need to take the molecular formula mass over what we just calculated. So, and this is very, very close to 1. Actually, it's like 0.99 something. So the n is 1. So my empirical formula is the same as my molecular formula. And some of you, again, just as I stated earlier in this video, some of you may be upset by that, thinking, well, why did we do all this work? Well, because that's life. All right, number 8. What is the molecular formula for each of the following? Paradichlorobenzene uses a moth repellent. Don't need to know that. The empirical formula is given here. The molar mass, the molecular mass is 147 grams per mole. So you're given the empirical formula, which is very nice. So all you have to do is determine the empirical formula mass to find the empirical or the molecular formula. So calculate the empirical formula mass, which is 73.496, and then we need to determine the molecular formula. Well, you're given, or you calculated this mass here, you were given this mass here. It's very close to 2. So here's our empirical, here's our molecular. You like that? These are typical AP exam questions right here. All right, letter B. A compound is 40% carbon, 6.71% hydrogen, 53.29% oxygen by mass. And the molecular mass is 180 grams per mole. So you're given percents. So what we need to do is determine the empirical formula first and foremost. So find out how many moles you have of each, and then whichever one of these is the smaller is going to be divided by the others. So here's my empirical formula. So it's a 1 to 2 to 1 ratio, which is right there. So my empirical formula is CH2O. And so now to find the molecular formula, we were given a molar mass of 180 grams per mole. So let's find out what the empirical formula mass is. So 30.026. And so you have 180 divided by 30.026 is approximately 6. So your molecular formula has a multiplier of 6. So it'll be C6H12O6. And it probably wouldn't be a bad idea to know what the name of that compound is. It's a very common sugar. C6H12O6 is, that's right, glucose. Okay, so probably learned that in biology a few years ago. All right, number 9. I would love to work this problem out, and I wish I would have told you guys ahead of time, but we haven't gone over balancing equations yet, so we'll save this question for a later time. And it'd make a great bonus question too. So I hope this video didn't go too quickly, but if you need to back it up or rewind it, by all means do that. And again, if you have any questions, don't hesitate to email me.